Hello.
Hello.
Hey.
Hi.
Hello, everyone. Hello,
Hello.
folks. Second. Okay.
What are you doing?
I have once a month back-to-back meetings with the board meeting of the foundation, and then okay. Are we complete? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Kamil, you haven't
Yeah,
signed
Martin.
up.
Yeah, as always.
Okay,
Okay,
let's
we are
get
ready.
started. It's in there. Let me fast track it. Awesome. Okay. Hi, everyone. Let's get started. And first thing, as always, let me remind you about the SPEC membership agreement, the participation guideline, the contribution guide, and the code of conduct. All are linked in the agenda, so if you need a refresher, you can have a look at them. Let's start with a round of introduction. And let me start with myself. I'm Michael. I'm the host today.
I'm Martin from Apollo.
Pascal from Chilifilm.
Sachin from Apollo.
I'm Steven from Netflix.
Kamil from the Guild, sorry.
Martin, your chat also has to introduce itself.
Oh yeah, let's see if that works.
And there's also needs to be an agenda item for Martin's cat.
Yeah.
Awesome.
Oh, I should also say I may have to walk out for a bit to get some food because I also have a meeting right after this. So I'll
Okay, don't worry.
keep on the audio, but turn off the video so you don't
Yeah.
have to watch me walk down the street.
Yeah, it should anyway just take 15 minutes to continue the discussion on the planning algorithm
Yeah.
that we had last week, and there were still things to do on that. So we continue down that path.
I was also expecting Pascal to put temporal logic on the agenda as well. We
I had
had
a
a conversation about that.
yeah, we had a conversation about that. It's quite interesting when you have a different version of a type in a schema. But that's probably another sub-spec that we have to write. But yeah, it's interesting that after all these years, you still run into problems with GraphQL that you haven't solved before, and you just look at it and think like, how is that gonna work?
Okay,
Okay,
should I pass over to you, Pascal?
I mean you can.
I did.
So I've opened the pull request for execution, updated the satisfiability pull request as well with a few changes. There's now also a to-do comment in it. And I've changed a few things from our last meeting. So first of all, I fixed Martin's issue. Let source schemas be an empty set. Now for each source schema in all source schemas, if source schema defines initial type, initial field, continue to the next, does not define, continue to the next, otherwise added. That reduces the initial set to not all source schemas, but to just the ones which define the schema, the first path. And from there on, just starting from the second element and then doing the same thing as last time. Yeah, it's still very rough, this algorithm, but the rough part is down here, and that's probably also where we should start a discussion today. Does this make sense? That we don't go through all source schemas to then go through all source schemas again? Okay. Great. Then the big question of today is, what do we do with these two functions? So we have isReachable and we have resolve requirement. And the easier one of the two is resolve requirement. Because essentially we are on one schema, we are on a type, we are on a field, and we get the requirements that we have to resolve. This is still super vague because requirements, what does this even mean? The moment it's just a list of required fields, but this can be arbitrarily complicated because you actually have different fields. You have the requirements on the arguments, so we have to merge requirements, and so it's gonna be more complicated than this. But just to have the rough structure now. Other schemas is all schemas except the one that we are currently on, because that's illegal. And then we say for each required field in requirements, we check, we get the path of the field because it could be deeply nested. And we initialize a variable, a Boolean. This is purposely done this way because I don't think that this will be everything that we have to put in here. Then we check on all the other schemas if we can resolve this requirement. So if other schema defines type and field path, if it's reachable, now the complicated one up here, returns true, then set can resolve to true and break. So essentially we do this for all of the requirements. And then if everything is resolvable, the requirement can be satisfied. That's essentially the story behind it. Now, why is this so complicated with can resolve? I initially thought that there's more cases than this, so just kept it in this shape. The question is a bit if there are other cases, and also if isReachable is the correct way of looking at it.
We haven't defined isReachable yet, right?
Well, it is kind of defined, but it's wrong.
isReachable is this plan option
Now
stuff.
reading this through, I'm actually not sure if other schemas.
What are you not sure about?
Well, while reading it, you always question everything, right? This is like the 5th iteration of this, so we need to have a source point as well, right?
What do you mean with source point, Pascal?
Well, this is the current schema. Okay, so this is the current
Yeah.
schema we're on, and this is the type and field which could come from a different schema.
Yeah. And
So-
on line 103, we are using both in isReachable, right?
Yeah.
But the
Schema
type
and other schema.
But it's
Yeah.
not the type that, yeah, it's a kind of the type is also available on our schema, right? But we want to transition to this field.
Yeah, but this is wrong because this line is wrong. Let auto schema be the set of all source schema exclude. I think we have to point to the other schema because we could resolve the requirement from our current position, technically.
What do you mean by?
So how resolve requirement is used is if current field on current type in candidate schema defines a requirement, and then we say if resolve requirement candidate schema current type current field returns a valid requirement, but this is wrong.
You mean because you're not aware from where you come?
We actually need to have both. We need to have the current schema in here as well.
So
we
that
want-
isReachable can avoid trying to resolve the requirements on its on the same schema, basically.
Yes, I believe that's the
So it's a from two.
Yeah, it's required for this one. Let order schema be the set of all source schemas excluding schema. So that's wrong because let order schema be the set of all source schemas
Wait.
including
Ah, yeah, because
candidate
can,
schema.
can you go to the upper part to the
Where it's used, you mean?
yeah, there is if current schema, candidate schema. Where do you get the candidate schemas from?
It's this nested loop.
Ah, okay, yeah. All good.
For
So
all
we
source,
are,
for all
yeah.
candidate schemas, we have to resolve the requirement.
But what is down here? Let other schemas. All source schemas excluding candidate schema. Excluding.
Because the current schema is fine. Like if we need to resolve a requirement,
Why do we need the current schema here? Oh yeah, no. You're transitioning to this. Okay, yeah.
to say is
So-
reachable, you have to transition to
No, it's candidate schema is correct. Like so when you transition to this new schema, there's a new field with requirement. It can get requirements from the part where you're transitioning from, but not from the candidate schema itself.
yeah. Sorry, from time for each. Yeah, what we completely miss here is that we also have a local schema. And then we actually know already.
But this is wrong, Pascal, because like it's perfectly fine to pass on stuff from the schema we are on
Exactly,
to the new candidate schema.
but that's it's a whole thing, right? If current schema, thank you, defines type and field path, so that can resolve to true.
But I think this is wrong because you're saying let other schemas be all source schemas, including candidate schema and current schema. The current schema is wrong there.
Yeah, but I mean, it doesn't matter. It doesn't
because
matter.
we are looking for requirements. You're excluding them for requirements of the field that we have on this candidate schema.
Yeah, I know, but it's not that we don't need to transition to another schema. Like this other schemas is only used for when we have to do transitions with it's reachable. But we are already on the current schema, so when we can resolve the requirement from the current schema, we don't have to transition.
No. It isn't. Oh, maybe I'm reading this wrong, but isn't that for requirements of the field we want to transition to?
Yes.
Yeah, but then it's totally fine to pass it on from the current schema.
Yes, and that's why I say we can transition, we can resolve a requirement of a field.
Okay, so you okay, I get you.
And we have to exclude the schema that defines the field because you cannot resolve requirements locally. But we are already on a schema which can resolve these. But there we don't need reachable. We can just check if we can define. I mean, there's more logic.
Yeah. Oh, good.
Here you also
Now I
have
understand that.
and then
If current schema defines type and field path. Okay.
other one is do this, but there's another thing. Oh no, that's actually true. I have to keep it like this. There's another thing that we have to check here. Because the field on the current schema could then again have requirements, right? That we have to resolve.
That's just recursive call.
Yeah. And then, yeah. So the tricky bit is, I think here we may find a few other cases and we have to align the algorithm so that it doesn't look bad. But I think this one is generally quite simple. You say that you need to resolve a requirement, and you can actually reuse the is reachable one to see if this requirement can be resolved or not. The tricky thing is, what do we do in is reachable? Because in is reachable, we have a target schema, a source schema, target schema, and a type. And what we have to do is we have to check if the lookups, so we get all the lookups for type from target schema, and then we get, for each lookup, we get all the keys, so essentially the arguments. This also is more complicated than this because we have to merge selection sets and selection maps and so on. And then we have to recursively call plan options. But I'm not sure how we're going to do this. Because essentially what we have to see is if the lookup is resolvable. But the lookup has parameters, right?
I mean, requirements.
No. Is reachable is used to check if a transition to a different source schema is possible. So in the algorithm where is reachable is used is when we plan the options for a path element. We essentially say we have current schema, we have candidate schema. Now we say that if the
I think you can treat the keys as requirements, right? So the keys that you derive from the lookup.
That's what I meant with their requirement. Because, like, this also how we actually implemented Pascal.
yeah, now we have
Because it's literally just field arguments that are required, like that. It's just the way we require them is a bit different because they are not relative to the type. But I mean that.
So then we don't have to recursively call plan options.
Well, but I think they are still relative to the type, right? They're relative to the current
Yes.
position.
Yeah, yes. Just standard requirements are like where the field is relative, and they are relative to the return type essentially of the field, or relative from where you branch off.
Yeah, and I think that should be the same in most cases, right? Because you're transitioning from one type to another, except for like abstract types when we get there.
Yeah. So
Then this explodes. Like that.
yeah. That could work. That could work. Now we just need to see that we don't have a loop. Oh yeah. I mean, loops are inherently a problem. Loops are inherently a problem. Okay, let's play through. So we get a path. We get the path elements. We extract initial type, initial field. We initialize an empty list of source schemas. We get the source schemas that define initial type, initial field. Then for each path element, we do the following. We initialize an empty set of next schemas. We set the current type and current field from the path element. And now we have these two nested loops. For each current schema in source schema, we try to resolve the next path, the next field, which could be from a different schema through a lookup or from our own schema. If the candidate schema does not define a current type, current field, we continue to the next candidate schema because this candidate schema does not define the field. If the candidate schema, that is wrong. Why is this in here? Let's comment this out.
Oh, sorry, I was muted. I was saying I think you meant equal. Yeah.
Yeah. If candidate schema equals current schema.
But you still want to add it, right?
Yeah, you want to add it.
Yeah.
You want to add it, right. So you have to get whoops, this one. So because that's fine. We are on the right schema already. Now, if not, we have to go there. Oh no, that's not wrong. That's wrong. If candidate schema equals, okay, I see. So it's this way. If candidate schema does not equal, we have to do all of this. That's correct. Because we still have to check for requirements on the current schema. So if the candidate schema is a different schema, then we have to go there. So we invoke is reachable from the current schema to the candidate schema on the current type. If we don't get, if it's not reachable, this field is not an option. So we continue to the next candidate schema. Now, if current field on current type in candidate schema defines a requirement, this has to be done for all schemas, including our own schema, right? We try to resolve requirements from the current schema to the candidate schema. On the current type and the current field. Yeah, I see now why we did it this way before. We do the check here because in it's reachable in resolve requirement, we don't really have this option. Okay. Where do we want to do the check from the requirement? Probably in its resolve requirement, right? If the requirement is not satisfied by the current schema, that's something that we already validate in resolve requirement. So then we can remove this. So Otherwise, add the candidate schema to next schemas. Cool. So we do these loops. If next schemas is empty, return an empty set. We cannot do anything more than that. I think that's, yeah. If we don't find any option, we have to return. And this can happen in any of the elements of the path.
Yeah.
We find options, we do the same thing again. We set the source schemas to the next schemas and then just proceed with the next path element. And this way we should visit all of the elements in the path. Now, when we do is reachable, we have source schema, target schema. If target schema does not define the type, obviously we return false. If source schema equals target schema, we return true. Technically correct. Otherwise, you get the lookups.
Yeah. It's technically correct, but it could also be a precondition of calling the is reachable. It feels a bit weird to say that it's reachable when it's the same. Yeah, something like that.
Okay. And we get the lookups from the target schema, which return the type. Now we try for each lookup in lookups to get the key fields. If key fields is empty, let's remove this because it probably will never.
That should never happen. Yeah.
Otherwise, it's a data field. Let key fields be the set of fields from the key. Okay, for each key field in key fields, we resolve the requirement. If this returns false, we essentially continue to the next lookup. I will make this a bit cleaner because we are in a nested loop here. Otherwise,
yeah. So the first match we return true. Yeah.
we only care about one. And then we have resolve requirement. Let requirements be the parsed. So requirements receives current schema, candidate schema. Could also probably should be source target, but different topic. Let requirements be the parsed selection set map from requirements on field. Let other schemas be the set of all source schema excluding candidate and current schema, because in both cases we cannot resolve the requirement. In this case, we cannot resolve the requirement, and in this case, we can resolve it maybe locally. For each required field in requirements, let field path be the path to the required field starting from type. I'm not sure about this one. The reason why it's field path is because a requirement could be a nested field, and I'm not sure what we're going to do here. Like technically, this could be a path.
But shouldn't resolve requirement be able to deal with that? Because that's true of normal requirements as well, right?
Yes. Do requirements, but requirements do not have to be resolved from one graph, right? Like I could have a requirement which essentially, if we have schema A, B, C, I could define a requirement on C which includes data from A and B nested.
Ah, so what you're saying is the key field should all come from one schema.
That's the question.
No, the key fields can, like if you have a composite key, it actually can come from.
It's not keys. It's not keys. It's requirements. So you can require whatever you like. You don't have the restriction of keys here. So
Yeah, but a requirement technically can also come from multiple schemas, right? Like if you're requiring an object, this object.
if the
Comes
let's
from-
say the composed requirement would be user profile name, then we would have one field which essentially is user profile name. Now what this means or could mean is that user is resolved from the user service, and then from the profile.name that could be resolved from the profile service through a lookup.
Yeah.
Lookup on user. So we may have to actually pick this path apart and loop through it. Also, we have to definitely be more specific what requirements is. It's super vague here. Let requirements be the parsed selection map from requirements on field. That should probably be a flat list of required fields, right? Or paths. It should be a flat list of paths. So when you have user profile name and ID, the output should be that you have these two requirements to resolve. Yeah, it's tricky because you would completely miss you would completely miss the transition here with this very dumb algorithm. Because there could be no schema that defines a field path starting from type because it's actually a composite. Can there be a field? No. There can, yeah. Technically, it's possible. So it could be that you have user.profile. That you get user profile from the user service and profile.name through a lookup from the profile service. And then there wouldn't be a type which defines a field path. Would we have to go through each element of this path again? I mean, technically, this is kind of what plan options already does. It would be nice to somehow reuse it.
Yeah, I think we originally talked about that, right?
Yeah, we did, but the interface of plan options at the moment is just the path, which has to start from the root.
Yeah.
But somehow this part now becomes really interesting, right? So
Yeah.
if we do something stupid now and just say, we say plan options internal, and we have the source schemas here, then technically we could just plan options on this, right? And pass in. So we could do something like, I mean, let's just be crazy and say if plan options internal field path. Oh. Yeah, we have to do it on both. So it's not only is reachable, it's actually a plan. It is a recursive plan options. Resolve requirement does a recursive plan options. Because you have the current schema. So essentially you would do something like this. Plan options internal, where the current schema is the first schema is your current position. Returns an empty set. continue to the next. And then we also don't need is reachable here, so we lose the recursive. I mean, we still have the recursiveness, just over a different node. But essentially would be this. And the same thing on the current schema as well. Like if, that's correct, plan options returns an empty set. Non-empty set. Yeah, so now this is obviously a bit messy, but that would still be okay. So let's play through. When we resolve requirement, we go from one schema. We have to resolve requirement from any schema. It could be the same one, but it can also be a different one. Requirement is always defined by type and field. Now, we initialize this auto schemas thing. Now, we get the field path to the required field starting from type.
Why do we separate the current schema and from other schemas? Like why can't other schemas include current schema?
So
Because we're doing the same thing here twice, right?
yeah, now we do. Now we do. Before we checked if we can reach the schema, but you're right. Now we can actually treat the current schema the same way because we just do plan options on it. The question is though, do we need to change the path? We probably don't even, yeah, we probably don't even have to change the path. Like it doesn't matter if this plan options internal starts from the root or not. And we also don't care about the lookup at this point in time.
Well, I mean, we do because we still need a valid transition. Like plan options currently assumes that you're starting for the query root, right?
Yeah,
Which
so
is
it's reachable it's nested, right? But then I expect this to be a never-ending loop. So we have to do an is reachable first.
doesn't that get us into a loop because is reachable calls resolve requirement?
Oh yeah, it does. It does. But it's kind of where we are at the moment. Well, it technically only calls it on the key fields.
Yeah.
But I mean, we there's now many places how you can get into a loop. You can also plan options internal calls resolve requirement, and we call plan options internal from resolve requirement. So you have to be careful about it. It could be that it still works.
It's good that we don't design airplanes, right?
I mean, it depends in which company you work, you know. There's two. One of them cares about it, the other one doesn't. Yeah. Yeah. So we do have to check if we can transition to this scheme, to this schema. And then we do a plan options once we know that we can reach the schema. Could work. The biggest problem is that we don't have a reference implementation, or we will never have a reference implementation of this because no one in his right mind would implement it that way. So I'm not sure how we validate that this algorithm works. On a whiteboard, maybe.
Yeah. That doesn't seem like a good foundation for a spec.
Yeah, I mean,
Very well said.
but it's what we want, right?
Well, I mean, I think we want something that could be implemented. Like it shouldn't be completely
It shouldn't
crazy.
lead into it shouldn't lead into disaster right away, right?
Yeah.
So maybe we do want some kind of reference implementation.
Any takers?
That's the problem. Yeah.
Yeah, so beware of the reference implementations, because like what we did with GraphQL.js, it's a very good reference implementation, but then people build on it.
Yeah. I mean, I think the term reference implementation is probably wrong for this.
Yeah. Yeah, you could basically implement this algorithm like as a kind of test case. But if you implement the whole thing, people will just build on it.
Yeah, I mean, I definitely have to have a fresh mind and not 9 hours of meetings on before to think this through. But what we have to care, I mean, we anyway also in satisfiability at the moment, we need to be careful about loops. And here we have multiple places. It's not only the recursiveness that we can run into issues, it's also what this completely doesn't validate is that you don't have recursive requirements.
Well, Pascal, do we have that in a pull request? What you're writing there now?
No, that's I will keep this to myself. You have to type it down if you want a copy of it.
No, but if
I'll
we
just
can
ask
share
the
it,
AI.
like, we can also find issues in it.
Yeah, no, it's fine. It's in a pull request. This what I'm typing now is not. I will just make a commit, a working commit with this, and then we can work on it in pull request. Same thing for satisfiability. Is pull request still open? Glenn has reviewed it already and has made a lot of comments. I would say most of them are already resolved, but I think we have to review this carefully. Like if anyone has a better idea on how to do things, just shoot. And otherwise we just iterate on this for another few weeks.
And maybe spend some time thinking about it in between.
Yeah, I mean that's the main issue with these work groups, right? I mean, I don't know how it always happens that it's Thursday so quickly. Like you have all the good intentions and then boom, suddenly it's Thursday again.
Same here.
But the thing is, I've seen this in other work groups. It doesn't matter how big the time span is between the work groups.
No, it's always the problem.
It's always the same thing. So if we have 2 weeks between the work groups, then you will run into the same issue. That on Thursday morning you wake up in your own sweat and you think, oh shit, we should have done something. Yeah, Okay,
Let's put that. We can look at that async, right? It doesn't have to be in the meeting, and then maybe we come up with a better way to deal with that.
that's great. So I expect you to so for the AI to take notes. The action item of Michael for next week is to have a function and fully working algorithm for the plan options algorithm. That's great. Including add AI, please add including a reference implementation of the whole specification.
But I mean, this is just validating. It's not really planning, right? Or what is it like? The intent for us is just to use it in satisfiability.
Yes, and to also make a note that this is how the observable execution behavior is from the outside. Because we don't define what subgraph or source schema queries are ran, we don't define when they are executed and whatever. But from a public API perspective, if any query is sent after satisfiability, plan options will figure out how to execute it. It will find a way to execute the query. It doesn't execute it, but it finds a way how to execute the query.
Yeah. Just from
Essentially, what it does, it's just a glue between the source schemas. It just walks through all possibilities and sees if there is one, and if there is, or if it checks what paths are there to go to navigate between the source schemas. The output also is just an array of options, a set of options. You don't get full working paths, but you have to resolve requirements and whatever. It only tells you that it is possible to resolve this path from, and you will be in these schemas in the end, essentially. But how you get there, you don't know. That's internal logic from plan options. It's very far away from an actual implementation. But that's not necessarily bad, because an actual implementation would be far more complicated from what we have here.
Yes, I mean ours is a lot more.
Yeah. So if we get there, then yeah.
But yeah,
It's the execution.
What do you think, Martin? Like, let's put it in a pull request and then comment on it.
I think that makes the most sense. Yeah.
Yeah.
Okay, let's do that. The 15 minutes are over anyway. That we planned for this. Okay, cool. I think we also have a new attendee today, Victor.
Yeah.
Hi, Victor. If you have time, it would be great if you can add yourself to today's agenda.
I already messaged him.
Okay,
Don't worry.
great, perfect, cool. Yeah, in that case, I will push this immediately, because otherwise I will forget it again for a week, and then
Yeah, and post the link to the Slack.
Yeah, can do that too.
Then we can all asynchronously look into it.
Sounds good.
Awesome.
Okay, cool. In that case, see you all next week.
See you next week.
See you next week, guys.
Bye.
Bye.